Today, we are going to talk about matched correlator in the data transmission. In our digital communications, we have a modulation schemes where the signals are transmitted with some modulation schemes like any amplitude shift keying, phase shift keying, and frequency shift keying, so that the signal is received at the receiver. So we need to receive the signal at maximum output, so that we need some correlator. So that is what the receiver which receives the maximum output through correlator.
Like to see the correlator as a matched filter. This is what the matched filter. So the signal plus noise is given to the filter and we are getting the output. And if at all we understand the output of this filter as a correlator, we would like to find out the relation. See here, this is what the convolution integral, convolutional output. So y of t. So y of t equal to x of t convolved with h of t. So this is what we write the convolutional integral. The output of this filter is taken as y of t integral minus infinity plus infinity x of tau h of t minus tau d tau. So this is where the one particular in number of correlators, the number of filters, one of the jth correlator we consider, so that h of j of t. So that is how the output of that particular concerned filter is yj of t. So that is where here the convolutional output is nothing but the integrating the product of each x the input and the time reversed and delayed version of that transfer function. That is the product, and we integrate for a minus infinity to plus infinity. We move this transfer function uh, from extreme side to left side to right side and get the product, and we summation, that is what integrating, accumulating, that is getting, that is nothing but the convolved output, convolutional output. So here the tau variable is considered as a intermediate variable. Now the sample is taken at a t equal to capital T seconds, so that is the signal during 0 to t. At the end of that pulse duration, we take t equal to capital T. And now yj of capital T is equal to integral 0 to t x of t hj capital T of t minus t of dt. So here in the place of t, capital T is replaced, t equal to tt, t equal to t seconds replaced, and in the place of tau, it is just substituted with another variable t. So now this is the convolved output you can consider, that is being correlated with any correlator. Suppose there are number of correlator, there are m number of correlators, m number of correlators. M number of correlators. One of the correlator you can consider, that is the product input and some function, a diagonal function or whatever the signal function that is being considered product and integrating 0 to t, that is the duration of the pulse or bit. So that is the output, we are getting the convolved output here. This is what y of t or whatever it is. So that is taken x j of t of xj is the output of this correlator. So our jth correlator xj is integral the sum product of x of t by j of t dt. So this is the correlator. So anyway, the output of this correlator can be taken as a by decision making, whether above threshold or below threshold, considered to be one of the signal that is to be uh, identified. So that is that is either binary 1 or binary 0. So based on the decision making, we understand. So, but however, the receiver output must be taken first of all the integrated output, which is correlator. Now, if you take this correlator output as well, the correlate the convolutional output of this phi j of t, and correlator output xj is xj of t like this. If you make equal and come and you understand the similarity, so that see this phi j of t is the function where we consider it as equivalent to the transfer function of this filter hj of capital T minus t. So then hj capital T minus t equal to phi j of t. So we understand this function is equivalent to the transfer function, which is time delayed version by t, which is time reverse. So here we can just replace h t, and this is what phi j of capital T minus t, we get the condition that is the impulse response of the correlator or matched filter. So this is the impulse response hj of t. So this is the matched filter, and this correlator is considered to be a matched receiver. Matched receiver. So where the impulse response h of t is considered to be phi of capital T minus t. So this is where time reversed, and delayed by t seconds. Time reversed and delayed by t seconds. So this is where it is nothing but this one. So now these m number of correlators, which is replaced each correlator, the transfer function of pi j, pi 1 of capital T minus t, pi 2 capital T minus t. These are the number of correlators. Then the received signal, whichever is matched, that is getting maximum output of one of the correlator, which gives the decision making, the observation where that particular correlator output is maximum. So other correlators obviously will be minimum. Only that one particular correlator output will be maximum. So that is what matched output for that correlator. So whenever for example, the received signal g of t or x of t. So this is what the pulse, for example, of t, okay, and h of t minus t or by so cap minus of t minus t, okay, t minus t. So this is where the transfer function, which is time reversed, okay. So this is where for t seconds, for example, this is what h of minus t, and delayed by t seconds, it is moving like this. It is moving like this, and then it will move up to here. It will move like this. So this is what h of minus t minus t. So now this output multiplied with this x of t or g of t, which gives the maximum output, where see here, this is the t, and again this is what delayed by t seconds, okay, which gives the output this one and this one. The product which gets the maximum. And as if it is moving further, it goes minimum. So this is what maximum output, that is the matched filter. Correlator output, the received signal, which is maximum. So that is what the example shows, the time reversed delayed by t seconds, that gives the maximum output and peak output. So this is what the matched receiver and a correlator receiver.